So the first thing you're going to see here is the definition of what vertical angles are. So vertical angles, and even within this, we have some definitions that you need to kind of recall that hopefully you saw that you were introduced to last year. The first one is the idea of array. Does that sound familiar to you? Do you do that now in Math 1? So there's three different little ideas. The one video that I gave you, you would have defined a segment. Segments look like this. It's a line, but have a distinct starting and ending point. Whereas if I do this, they both go on left and right forever. So this is what we would call a segment. This is what we call a line because they go on forever. Well, if these both have endpoints, these both have non-endpoints. The drawing that I would draw, if one of them has an endpoint and one of them doesn't, so it goes on forever, this would be what we call a ray. So real quick, summary of some definitions. Again, hopefully you've seen that at some point. If not, those are the three things that we want to kind of recall and be able to use. Okay. So vertical angles are rays forming the sides of one angle and the rays forming the sides of another angle. It's really even simpler than that. But if we kind of look at this angle right here, this angle is formed by this ray here and this ray right here. Well, we also have rays that are opposite of my red rays. So that would be this ray right here is opposite of this one. And then this ray right here is opposite of that one. So we have two red ones that create angle 2. And then opposite of those, we have rays creating angle number 4. So these are what we would call then the angles formed by those opposite rays are what we would call vertical angles. Okay. At the same time, we also have vertical angles here. So if we look at this red one on the right and the black one on the right, we also have opposite rays over here. The red one is opposite of the red one on the right. The black one on the left is opposite of the black one on the right. So these are also what we would call vertical angles. The easiest way to kind of think of it is they're basically across from each other. All right. So if we have two lines that intersect, you're always going to get 4 angles. The angles that are across from each other are your vertical angles. Okay. The theorem then that's attached to these, pretty simple. Vertical angles are always congruent. All right. Congruent, another thing that I think, again, you were introduced to this idea last year. Congruent is this little symbol. So you basically have an equal sign with a little squiggly over the top. What that basically means is they have the same degree measure. So the way we're going to write it for this one, we would say that angle 1 would be congruent to whatever its vertical angle is, and that's the one directly across from it. So the blue angles are the ones that are across from each other. So angle 1 is congruent to angle 3. That would also mean that angle 2 is congruent to angle 4. What that will ultimately mean here in some of our problems, so don't necessarily change this. You're going to have some problems that show you this in a second. If angle 2 is 110 degrees, that means angle 4 has to be 110 degrees. That's what that basically means. They have the same degree measure. Okay, that's what congruency implies. All right. And that's what these problems now get at. So if you look at number 7, I'm telling you that angle 5, so this guy right here, is equal to 2x plus 7. And then I am telling you that angle 6 is x plus 25. And then I want you to ultimately find angle 5, the measure of angle 5, and the measure of angle PKU. So what we hopefully recognize, this is very much the same exact drawing that we had right here. We have vertical angles in angles 5 and 6. So when we look at that, what we understand is our theorem is vertical angles are congruent. So that means angle 5 is congruent to angle 6. Those have to have the same degree measure. Now, we have to do a little algebra for this one. We know what angle 5 is equivalent to in this case. Angle 5 is equivalent to 2x plus a7. So I'm going to say that 2x plus 7 would have to be equivalent to angle 6. And we also know what angle 6 is defined as. Angle 6 is given to you as x plus 25. All right. So that's where kind of the little algebra equation comes from. Once we have those set equal, you're just going to go through that, solve that equation. All right. So to solve this, we're going to subtract this x over so that those are going to cancel. If I did 2x minus this 1x right here, I just get the 1x plus a 7 equals 25. Subtract that 7 over, and we get x equals 18. And then again, I try to give you a heads up. Eventually, when we do get to a quiz assignments, answer the question. It's really, really easy to think this is your answer. But if you look at this question, the answer to the question is, what's the measure of angle 5 and what's the measure of PKU? So you are not done. All right. A lot of times when we solve equations, that x is your final answer. We just needed this in order to actually answer these questions. So to answer these now, isn't angle 5 equivalent to twice the x value increased by 7? So for me to now find angle 5, so I'm going to do the measure of angle 5. I'm going to take this expression right here, this 2x plus 7, and I now know what x is. So instead of putting the variable x right here, we now know that our x is this 18. So we're going to slot the 18 in there. And then whatever that evaluates to be, we now know that needs to be the measure of angle 5. All right. So 2 times 18 is 36. Add in a 7. What is 36 and 7? That should give us 43 degrees. All right. So we know that this is a 43-degree angle. So I'm just going to write over the top of it because it's easy for me to do. You may not want to do that. What do we then know angle 6 has to be? Yeah, it's got to be 43 as well. That's our vertical angle. Those are congruent to each other. Answer this question now. See what we remember from yesterday then. Find the measure, and then if you watch that video on Friday, because we talked about how we name angles, how we can identify what that angle is. So find angle PKU, and then once you've identified what angle that is, identify what that degree measure is going to be. I'm actually going to do this in yellow for a second. So let's see here. So find that angle first. This goes back to Friday's little video. How do we name angles? What does that give you? Once you know what that angle is, what is its degree measure? Okay, let's see if we can get that. New flip flops? Yeah. Fancy. Toasty. Perfect for a cold winter morning. Okay. Hopefully you're getting there. First thing again, identify what is angle PKU. And then once we have that, we can find that using what we did yesterday. Okay, if we went back to the first page of notes that you have right now, we could figure that out. So the angle first, this will be hard for me to ask anybody. So let's kind of talk about what this is. If I want angle PKU, that's actually kind of a little map, a little road map. P to K to U. We're going to go in that order from point P to point K to point U. So if I do that, here's point P. I'm then going to go to point K. And then I'm going to go to point U. So when you look at that, look and identify what angle got formed right there. That forms this angle right here. So this is angle PKU. That's the angle that we are looking for. All right. Anybody get that? Have that? What would that angle need to be? Monica? Good. 137 degrees. And how did you know that, Monica? Because you remember our fancy math definition yesterday. What was this called? Okay, good. So she actually used Friday's definition, that these are supplementary because supplementary angles make a straight line. Yesterday, our definition was a linear pair. This makes a straight line. And these two angles then are a linear pair, but same idea as supplementary. These have to add up to be 180. So she just took the total amount of 180, subtracted away this blue angle, and the difference is 137. So that had to have been this angle here. All right. And if I ask you what's the other angle, this would have to be 137 as well, because it's opposite of that 137. Again, a lot of different kind of ways we can ask these questions. All right. Okay, no more theorems. This back page is just some problems now. Can we kind of put those 3 or 4 theorems from the last 2 days, yesterday and today, together? Do 1 and 2. These should be nice. Pull out a calculator. You're probably going to need some calculators today. But do 1 and 2. This is the easiest theorem you're going to deal with this whole module, next couple module. All right, and tell me what those 2 values are. All right, number 1, Lily. What'd you get, Lily?
I got 75.
Good. This angle should be 75 degrees. How'd you get that, Lily?
I added up 58 and 47, which is 105, and then subtracted 180.
Good. And your thought process might be a little bit different, but she added these 2 up. What does that give us? 105. So these together add up to be 105. And then she said she knew that there's 180 degrees total in a triangle. All 3 of these will always add up to be 180. So if we've already got 105 accounted for, she subtracted away the 105 that we knew, and that leaves us with 75 remaining for that last angle. Okay. All right, Ben, number 2. What'd you get, Ben?
63.
And how'd you do that, Ben?
96 plus 21 is 117, and then 63 equals 180.
Good. So he did it similar to what Lily did. He added these 2 up to get 117, and then he knew there was 180 total. So we just subtracted away the 2 that he knew, leaves you with 63 remaining for the last one. Okay. Those 2 should be nice. Those you can kind of do just mathematically. You don't have to worry about any algebra. 3 is the same idea, but now you're going to have to use a little algebra. So now solve number 3. This is where there are some different routes. I think yesterday when we did these, people did these a couple of different ways. But same exact theorem, the idea that inside of a triangle, they always add up to be 180 degrees, except now you're going to have to do a little bit of algebra. You have to do some solving of an equation. we just need to get it right. So you're have some solid thoughts. We tell how do we use that 59? Because that is one way that some people are going to do this. But what you did next. No, what this is saying, all of these have to add. So what you're doing is taking that amount and getting rid of these two. Doesn't this whole angle need to equal 59? So this, that would work. That's some guessing and checking. It's reasonable. If this is a decimal or a fraction, that x value that could be tricky. But yeah, that's ultimately what you're trying to figure out is how can I make this equal 59? Well, think about what I just said. How do I make that equal 59? Equal 40. Because can I just take this and set it equal to 59? Okay, you do that. It's 100% correct, so you do that. Okay, so there's two ways that I would think we can do it. There's actually a third way in play. We're going to see if CM can come up with that third way in a second. All right. So there's a few different ways here. Tyler, how did you do yours?
I did 90 plus 31 plus 3x minus 1 equals 180.
Good. So that's one way that we can definitely do this. Is just the idea that this angle here, and this angle here better all add up to be 90. So we took the three angles. Here's the first one. Here's the second one. Here's the third one. Add them up. Or not 90. Add them up. They have to add up to equal that 180 degrees always. Okay. All right, Ella, how did you set up yours?
I started by adding 90 and 31.
Good. So she did 90 and 31, kind of along the lines of what Ben and Lily did before. And that gives you 121. And then you did what?
And then I subtracted it from 90.
Good. So again, same thing Ben and Lily did in the previous one. And that gives us how many degrees?
59.
Good. So what that means is, doesn't this angle right here, doesn't this have to equal a 59 degree angle? Yeah. So then what'd you do?
Then I took 3x minus 1 and I made it equal to 59.
Good. Then we just take that expression here. When would 3x minus 1 equal a 59? So that's how Ella did it. That's a second way to do this. Now, Seaham, have you come up with it yet? Seaham basically did kind of the same thing. She doesn't like algebra maybe because she didn't set these equal to each other. She just understood that she needed to figure out what x value, what number could she assign right here, multiply it by 3, and then decrease it by 1 to equal a 59. She just did a little guessing and checking. What did you get, Seaham?
I put 3 times 20.
Good. So she said right away that x has to be 20. So now let's test that. What is 3 times 20? 60. And if I did 60 minus 1, does that give us the 59 degrees that we're supposed to? Yeah. So the answer to this question is 20. She did a little guessing and checking, kind of along the lines of what Ella did. But now if we solve these two equations that Ella and Tyler gave us, so if I add that 1 over and then I divide by 3, wouldn't this also have told us that x is a 20? Okay. If we do it the way that Tyler did it, add these all up. So 90, 31, what is that? 120 plus 3x equals 180 if we combine like terms. If we now continue to solve his equation, we get right back to this 3x equals 60. Wouldn't this also give you a 20? Okay, so a lot of different thought processes we can kind of go through when we're doing these, and it's really going to be how you see it, as long as we can do the work correctly from there. Okay, so 1, 2, and 3 all deal with the idea that inside of a triangle is 180 degrees. All right, number 4, answer number 4. See what we think for 4 if you haven't done that one yet. Is that not numbered 4? Yeah, I don't have a number there. Do this problem here, this guy. Because again, there are really 2 to 3 different ways, very, very much all correct, that you could approach this problem with. So the people that are getting it are using the theorem from yesterday, which is great. That's ultimately kind of long-term, the simplest, easiest way to go about it. So there is a little theorem for this. So if we went back to the first page, we have this here, that the exterior angle of a triangle, so the angle that's just outside of this triangle, that angle is going to equal, where is it? The measure of the exterior angle is equal to the sum of the opposite interior angles, the ones that are across from them. So the ones that I'm seeing people do that are getting this correct so far, they're recognizing that that's what that theorem is. Here is your triangle. So let me make clear on this, because the mistake I'm seeing of the people that I've seen, is this 100 actually inside the triangle? No. So that is not a 100-degree angle. So we can't use yet what we did in those first three. So the people that are kind of setting this up using that exterior angle theorem is the idea that this angle here must equal the sum of the two interior angles that are opposite of it. Well, one of those angles is 2x plus a 3. The other angle is a 51. All right, so a number of people set that up, which is good. All right, 100% correct. That's really what I want you to do. I think that's the easiest, most efficient way to go about this. This exterior angle is equivalent to the opposite interior angles added together. We then just kind of go through the algebra here. 2x plus 54 as we combine these like terms. Subtract that 54 over. So that we get what? 46 equals 2x. Divide both sides by 2. And our x should be 23. Okay. Now, here's what a lot of you were doing. That we were trying to do. We were trying to use the theorem from the first three problems. And you can do that, but you have to understand. Let me do it in blue so it just is much more clear. This is that third angle, interior angle. Can't we figure that out pretty quickly, though, if we wanted to do what a lot of us were trying to do? What does this angle have to be right here? What does that interior angle have to be? What's that?
49.
Now 49. Ben? 80. Because isn't this a straight line? And doesn't a straight line always equal 180 degrees? So if I have 100 of it right here and I complete it, this angle and this angle better add up to be 180 degrees. Then you guys that were trying to do what we did on the previous ones, you can now do that. So now we could go ahead and do the 180, and these are the two we want to get rid of. That's 131. And you're going to get that 59, and then take this, set it equal to 59, and now you're going to get the same exact answer, okay, if you go through it that way. Or is it 49? Sorry, 49. All right, so there, again, just some different routes that we could take there. All right, do number 5. This one, crossing my fingers, is today's notes. These angles are opposite of each other. So we talked about what that means. If our angles are opposite of each other, we gave them a name. We talked about what that meant. Yes, ma'am. To where? Yeah, you have something to give her. Yeah. All right, just to make sure we kind of get through these, we don't run out of time here. These angles are opposite of each other. You could actually call them opposite angles. Some books will refer to them as opposite angles. In our case, we call them vertical angles. They're opposite of each other. And what we said earlier is that vertical angles, which is what 5 and 6 are, they are congruent, which means their degree measures are the same. So basically what that means is the measure of angle 5 has to be equivalent to the measure of angle 6. Those are equal, basically. Because they are equal, we just set them equal to each other. So angle 5 is 2x plus a7. Angle 6 is x plus a25. And then you just solve that equation. All right. Is that the same one we did earlier? Either way, solve that. So we'll subtract this x over. Subtract your 7 over. Again, answer the question. 18 is not your answer. We need that. It's, again, easy to think that once you've solved for x, you're done with the problem. But what the question is ultimately asking you is, what is the measure of angle 5? Angle 5 is this expression right here. So we now need to plug in 18 for that expression. So the measure of angle 5 is equal to, take your 2x plus a 7. And instead of the x right here, we're slotting in a 17. All right, and that should give you 43 degrees. All right. Okay, same idea. Do number 6. We'll wrap up with that one. Okay, let's see where we're at with this. Same idea. These are opposite of each other. So that's what we call vertical angles. They're directly across from each other, created by those two lines. Those have to be equal degree measures. So because vertical angles are congruent to each other, we're going to take this 2x plus a 5, because that's angle 4. It has to have the same exact degree measure as angle 3, which is x plus a 30. So those get set equal to each other. Oops, wrote that wrong here. And then you just solve that equation to get your x. Subtract your 5. So we should get x to be 25. And then again, all of these, make sure if that's your answer or not, because this isn't your answer. What we want is the measure of angle 4. Angle 4 is twice x plus 5. So the measure of angle 4 is twice x plus 5. And we now know that our x is 25. Simplify that. So this will be 50 plus a 5. Measure of angle 4 is 55 degrees. Okay. Okay. You got your homework here. This should make you think a little bit. So do your best. Certainly, if you have questions on that, be prepared to ask those tomorrow. A lot of stuff going on here. Okay. Typically, you're either setting them equal to something, to each other, or you're going to be adding it up, 180, things like that. But again, try this. I'm curious how this goes the first time around. Okay. So we'll collect this tomorrow. 35. Okay, let's go. Save this right.